Okay, so we're going to continue on with the ideal gas law, but we're going to look at a different way to manipulate this. So if we had a capital M, this is going to be our molecular mass. And this is what we've been finding for a while now. So 1 mole equals 18 grams of water. That's our molecular mass. So we could use this to also figure out the volume of a gas that would be produced in the lab. Now, there's two ways that we could use this capital M. We could take the mass of the sample that we have, multiply by the gas constant and the temperature in Kelvin, and divide by pressure and volume. This would be one way to use the molecular mass to figure out any one of these things. Okay. The other thing that we could do is we could also use density times the gas constant over temperature to pressure. Now notice this one's slightly different because you're not going to have volume on the bottom, because remember density is mass per volume. So by putting it up here, it's automatically going to cross itself out with the gas constant, so there's not volume on the bottom. Okay, so these are the two things that our capital M could use. So we're going to look at the problem on page 438, number 46 is the first one that we're going to look at. My pen's kind of lagging behind here. All right, so on number 46, it wants to know how many grams of gas are present. So we're going to be looking for the little m, okay? If we have a molar mass of 70.0 grams per mole, so this is our big M, we have occupying a space of 2 liters. It's 117 kilopascals, what the pressure is being kept at, and 35.1 degrees Celsius. Now, we know we're going to deal with Kelvin, so we're going to go ahead and change that 35.1 right now by adding 273, and we're going to end up with 308.1 Kelvin. We don't even want to keep that there so we don't mess ourselves up. We'll just go ahead and change it over to Kelvin. So now, let's take a look at what we have here. We're trying to get to little m. So you're going to do a little algebra here to get this guy alone. First of all, we're going to multiply PV over to the other side to get the mass alone. Okay, so it's just a little algebra. How do we get him alone? Last piece then is we would divide by RT to get the mass of the sample left alone. So this is what we're looking at. So for our pressure, we had the 117 kilopascal. We have 2 liters. And our molar mass, we said, was 70 grams per mole. And this is actually 70.0 for sig figs. All right, on the bottom, our constant. Since we're dealing with kilopascal, we're going to use the 8.314. Okay, so remember you have those choices on page 435 for your different gas constants. We're going to go with the 8.314, if my pen would behave here, sorry. Liters times kilopascal over moles times Kelvin. Okay, and then the last thing that we're multiplying by is our temp, which was 308.1 Kelvin. My pen is really not going to make it here. All right, so let's cross off our labels. Kilopascal is going to go away. Liter is going to go away. Mole is going to go away. Kelvin's going to go away. Notice you're left with grams, which is what we want. So like I said, the labels are very important. I know they're time consuming. I know they're a pain, but they're really going to be important as we throw this back into stoichiometry. So we're going to take 117 times 2 times 70 equals divided by the items on the bottom. Remember, the parentheses are very important to use, otherwise you're going to get yourself into a wrong answer. So I'm going to go left parenthesis 8.314, sorry, calculator issue, times 308.1 on the Kelvin equals, and I'm going to end up with 6.39 grams of the gas. Okay, so when we go through, we are just manipulating to get to our smaller mass. This gives us the information needed, and we just manipulate the equation. You want to continue on page 438 with problems 47 through 50. They're all going to deal with either using the molar mass or molecular mass to get to the mass of the sample, or you might be figuring out the density of the gas. So continue with those problems. That's as far as you're going to go today in class. Tomorrow we start putting this in with the stoichiometry and we see how it works. We're going to start marrying the two concepts, which is going to lead you into the lab that we did on Friday where you're going to catch the gas. We're going to determine actually how much gas you should have gotten and how much you're going to get when you do this later this week. All right. If you have any questions, you guys can email me or text me. You know how to get a hold of me. We will go through this a little bit in class tomorrow, but we will not go through the problems individually because I do need to get you start going with the stoichiometry with it.